And now let's quickly look to this code, and then we have to cover another machine learning model also. So basically we will cover three machine learning model. We have covered linear regression, right? And now we are looking at decision tree, and then we will look at another classification model, that is basically your KNN, okay, or K nearest neighbors.
Okay.
Okay, so have you heard about KNN?
Canon or Kanban?
And this KNN, K nearest neighbors, KNN.
I heard one Canon report,
Okay, okay, no.
Kanban.
No,
Okay,
no,
that
no,
is
no.
from
I think that should,
BS.
yeah. So I think that should be little different. Yeah.
Yeah, okay. Yeah,
So,
let's see.
and this decision tree, were you familiar about this earlier? Means, have you heard about
Mm-hmm.
this?
Yes.
Okay. Yeah. So, this decision tree, we are using this algorithm, right? So this is your
Mm-hmm.
already pre-trained model here, in the same pandas library here, and we have created a demo data set. Okay, the same
Okay.
data set that I have used there. And this, you have gender, occupation and preferences. Okay, so if we plot this data, you will get something like this.
Mm-hmm.
In the first column you have gender, and the second column you have occupation and preferences, right?
Yes.
I think some values may be different here, like
That
right,
is fine.
we will be seeing that. So now we are converting this data frame into numbers, right? Basically, since these are your categorical variables, so we will convert this into numbers. We will specify them with numbers, right? So if you remember, this was your ordinal encoding, right? We were having two encoding
Mm-hmm.
methods. So this is your ordinal
Mm-hmm.
encoding. We are specifying some values to them, like male 0, female 1, student 0, programmers 1, PUBG 0, WhatsApp 1, GitHub 2, right? So if you plot this data, it will look something like this. 0,
Uh,
yeah, please say.
Here, can you just write it down encoding something?
Yeah, so I can write that.
No, no, that is, yeah.
Mhm.
No, especially this, yeah. Next thing, DF
Okay, okay.
gender. Next to female, yeah. It will help me. This terminology is really
Yeah,
hard
yeah,
to,
yeah.
yeah.
That was your ordinal encoding, right?
Yeah,
Ordinal
ordinal, yeah.
encoding.
Ordinal,
Okay. So yes, so after plotting this data, it will look something like this. At the 0,
yes,
0,
yeah.
it was your male, right? So if you look at the 0, 0, it was your male, and then we have two female, that means 0, 1, 1. Then again male, so you have 0. Again female 1, then 0, 0, right? And similarly for occupations as well. And if we, for preferences, you will see that we have three categories, right? GitHub 2,
Yeah.
right? So it is at the end we have a GitHub, so it is there replaced with this value 2. Okay,
Mm.
so just remember this one thing, that every time, like, you cannot use this technique to convert to your numerical variable, like sometime, like, since it was a decision tree, so might be the case that here the it will not give some sorry, the errors. But if you use this technique on your linear regression or some other algorithms, it might give you some error, right? Why? Because if you see here, we are ranking them.
Yes, yeah.
We are ranking the, like, PUBG from ascending order,
Zero.
right?
Mm.
We are saying that WhatsApp is greater than PUBG, right? Basically, these
Mm.
numbers specify that.
The next one. Yes,
So
yeah.
it might bring some data integrity issue, right? So it may
Mm-hmm.
bring some challenges,
Yes,
or
yeah.
the accuracy might be not that good, right?
Mm-hmm.
So that
Mm-hmm.
we can use like your one hot encoding, right?
Mm-hmm.
If you remember that we convert all the values other than that particular category as 0, and for that value we write at 1, right?
Mm-hmm.
So that can be a good solution to handle that. Okay, so once your this
Okay.
data set is generated, converted
Mm-hmm.
into your DF, right? Now we will separate the features and labels, right? Like your
Mm-hmm.
dependent set and your sorry, independent set and your dependent set,
Mm-hmm.
right?
Yeah.
So features and labels. Okay, basically your gender, occupation, and your preferences. And now here we are creating this model, and inside this model we are giving this data to it, right? So here we are specifying that create a object that is your model, which is your decision tree, right? And inside that model we are using a fit function. Okay, inside that fit function we have to pass two parameters. One is your feature and one is your target value or your label. Okay, that is y. And once you have done that, your model has been created. Now you can just give some input values and it will be giving you output. Okay, now that's your decision tree is completed. Now it will create some values. If you remember here, this it will give you some root node on the basis of which it will give you some condition, yes or no, right? So it decides some rules, right? On the basis of which it will be making some conditions, right? Like here it said gender, if the gender is lesser than 0.5, that means if the gender is 0, right? Since here we have used the 0 and 1, so here we are having 0.5. Like if the gender is here 0, see, lesser than 0.5 means 0 and the greater than 0.5 means 1. Okay,
1, yeah.
so if your gender is lesser than 0.5, that means if your gender is 1, right? If your gender is 1, if your gender is a female, that means, right? If your gender is female and has occupation of 1, that means if your gender is female and has occupation of 1, occupation of 1 was programmer, right? Female programmer, then what should be the output? That the class should be 0. What for the class of 0? Again I think we missed something. Class 1, right? Sorry, occupation 1, sorry, occupation 0, right? Lesser than 0.5 means if your female has occupation 0, occupation 0 is your student, female, that is your student. Basically we don't have any female student. Okay, so we may say occupation is equals to 1, right? The gender is female, gender is female and occupation is 1, greater than 5, that means occupation is 1. Now you can say occupation 1 is programmer, right? So gender female, occupation 1 programmer. So the preference will be, your preference is your class 2. So the class 2 is GitHub. Again,
No, it's male, right?
2. Wait, for gender, like if it's male, so it is saying class 1, class 1 WhatsApp. If it's male, again, are we missing something?
Yeah, in go down, actually here occupation is 1, greater than 5 means 1, right?
Greater
Female,
than 5.
1.
Yeah, so this is 1.
Yeah, 1, right? Then class is
2.
Yeah.
Occupation 1 and class female. No, sorry, this was for male, right? So it is like 0. Again we have confused basically in the points. Like it is 0 gender, and that is smaller than 0.5.
Yeah.
So it is 0.
0 means
So 0 means your male. So we were checking for male, female, sorry, it was your male, right? So for male,
and GitHub.
yeah, for male, if it is 1, occupation is 1, then you have class 2. So let's check occupation 1, programmer, male programmer is
Programmer.
Mail program is getter,
Getter.
right? Class 2.
Yeah. Mm-hmm.
So this is the rules, right? If your
Mm-hmm.
occupation is 0, your class is 0.
Yeah.
Occupation is student, class is 0, PUBG,
Yeah.
right? So this is how your
Mm-hmm.
rules are set by this model on itself. Like it's
Mm-hmm.
selected the category, right? Uh,
Mm-hmm.
this it's decided the which column should be considered as root node. Then it
Mm-hmm.
sets some splitting criteria, right? And then it's also
Mm-hmm.
set some subsequent
Mm-hmm.
decision nodes, right?
Yes. Yes. Yeah.
Basically this created some rules. On the basis of this, if we give some new input value, it will be giving us the output, right?
So these kind of rules,
Hmm.
it comes with the requirement, right?
With the
We can't decide anything.
no no no
Requirement.
no no no
And,
it come with the your model, like the model will decides itself on the basis of some uh, rules.
yeah. Yeah.
Okay.
I'm saying like this one, like
Hmm.
scroll up, please. Scroll up, please. One more. Yeah, this one we can use the PUBG 0 as you said, like it ascending order, right? This kind of thing
Hmm.
we can decide, or
No, yeah, we can
um,
decide this. Like you can change this.
okay.
This is a user input. Like here the just we can change like values
Yeah,
here.
use yeah.
Like let
We
me
can change the value. Yeah, yeah.
yeah
But there, if there is this one, we
yeah.
no. See, if the data is bulk, right? It's large amount of data, so we can't decide like it also depends on the requirement, right? As you said, like we have to understand the business. Accordingly, we have to
No,
decide or
actually,
how does it. Mm.
actually it does not, because see here just we are creating categorical variable into numerical variables
Okay.
here,
Okay.
right?
Mm-hmm.
Just have to remember that
Mm.
which number has been used to denote which category basically. Like here,
Category. Yeah.
if you
Mm.
see class 2, right?
Mm-hmm.
Now what we will do is, now here you are seeing these values, right? Now again we will convert from these numbers to back to categories, and now at this
Mm.
time we have to remember that which value have we have used earlier, and that's it.
Mm-hmm.
Like here
Um,
again we will create a like a line of code that if your
mm-hmm.
class is returning 0, then you have to
Mm-hmm.
display on the output PUBG, because our at end user don't know what 0 is, right?
Yeah. Yes. That's my question. Okay. Mm-hmm.
So
Okay.
basically
Okay.
the we have to specify the new line before showing it to the user. Like we cannot show the user like 0 or 2 or 1.
Yes. Yes. If they won't understand. Okay. Now that point I got you. Okay.
Yeah.
Might be. Yeah. I will try one more. Maybe
Okay.
I will come up with something, or I will be okay. Let's see. Yeah.
Okay.
Yeah.
Okay.
Go ahead.
So now we can start with your KNN. Okay. If this
Mm-hmm.
is makes sense, if this algorithm makes sense to you, right? Like this is a
Mm-hmm.
pretty basic example. Like you can go with on some like complexity. You can add complexity to it by reading some
Mm-hmm.
articles or like blogs, right? Okay.
So,
It will give you some hyperparameter, or you can change some values like that. Okay.
mm-hmm. Mm-hmm.
Now let's look for your k nearest neighbors, right? It is also a
Mm-hmm.
interesting algorithm, works similar to like the similar for your linear regression, and like it's the combination of your linear regression and your decision tree.
Oh, okay.